Then, what's the process for the x-intercepts? Set the numerator. And the numerator is which part? Top, right? So set 4x minus 8 equal to 0. This is a linear equation, everyone, right? The method for solving a linear equation is to isolate x, get x by itself. So we'll move the 8 over, divide by 4, and we'll have an answer. So add 8 to both sides. Divide by 4, we get 2. Right? Christian, sir. What is that on my graph? X equals 2. What is that going to be on my graph?
It's going to be an answer of points on the x-axis.
It's going to be a point on the x-axis. So everyone understand, this is going to be a point on the x-axis. All right. Step 3, Laura K. I think you're on step 4. Oh, step 3.
Oh, sorry.
That's all right.
Find the vertical asymptote.
Okay, so how do we find the vertical asymptotes, Laura?
You said the
Denominator to 0, right? What type of equation is that, everyone? Quadratic. Okay, so when we talked about quadratics, we talked about one of the things you want to do is look at it and see, like, are you missing the constant term? Are you missing the x term? Or are all the terms there? Because they were kind of different ways of solving it. This one is missing the constant term, isn't it? So what is the method you use to solve that one? I'll take a volunteer on this one. What's the method you can use to solve that one? What's the easiest method to solve that if you're missing the constant term? That's if you're missing the x term.
Factor GCF.
Just factor GCF. Look at it right now. Both those terms have x in them, right? So just factor an x out. You're left with x plus 8. Right? Set each factor to 0 now, right? So Marcus, what are we going to get for our solutions here?
X equals 0 and x equals -8.
X is 0 and x is -8. Good. Everyone with that? Yes? Gia. Where's Gia at? No Gia? Paris. What are these on our graph, Paris?
Those are, I think that's going to be our vertical dotted line.
Vertical dotted line. These are our vertical dotted barriers. I'm going to call them barriers. I really like that. Right? They're a barrier. They act like this wall that our function cannot cross as we're trying to draw it. And so it forces our function to go up or down. Remember seeing those earlier? Okay. Step 4, Rastim. What is step 4? If we have the horizontals, so what are we looking at, Rastim? Okay, good. So tell me what is the degree of the numerator in this problem? 1. What's the degree of the denominator in this problem? Is 2. Everyone good with that? So in this particular case, the numerator's degree is smaller than the denominator's degree. Rastim, what case are we in then? I gave us 3 cases. What case is it when the numerator was smaller than the denominator?
X-axis is the horizontal asymptote.
So it's case A? Everyone follow? We're in case A in your notes. We're in the case where the x-axis automatically becomes your horizontal asymptote, all right? Only because we're in case A, right? Case A says automatically we are in this. Now, I didn't talk too much about these. I said these were going to be magnets, right? That pull your function off. Yes? I want to add something to that. It's very important when we go to graph this. This is going to be horizontal, dotted magnet. But here's the part I want you to make sure you understand. You only draw this at the ends. Ends only. You'll see when I go to draw the graph what I mean by that. This step right here, step 4, only gives you the end behavior. It does not tell you what's happening in the middle of the function. It only tells you what happens at the edges. And this says that at the edges, our graph gets pulled down to the x-axis. You'll see why that's important in a second. All right, moving along. Brianna P., are you good right now, or you sure?
Yeah.
I just want to know what step 5 is.
You put all input.
Yeah, we're going to put all the information together now, all right? So I'm going to erase so that I have a little more room to do this. Everyone's got this information down. This picture I draw is probably going to wind up being my final picture, all right? Yes,
In the middle, you said the x0 and x minus 8 is vertical dot on the barrier. So these are like on the x-axis, right? Like on
Yeah.
the horizontal axis.
Well, let me draw them. Let me draw. I think once I draw this, you'll see it all come together. All right. So I'm going to draw my y-axis. I'm going to draw my x-axis. And Brianna will stick with you. I'm supposed to put all the information that I've found from steps 2 through 4 on this. So let's start with step 2. What did step 2 tell us we had?
That
At x equals 2, I'm going to draw what?
a point on the
A point on the x-axis. 1, 2, I draw a point on the x-axis. Everyone agree that's from step 2? Okay. All right, we'll move on. Jared? What information do I have from step 3?
We have x equals 0 and x equals -8.
X equals 0, -8. So here's x is 0. Let me get -8 here. 1, 2, 3, 4, 6, 7, 8. -8. And what do we have there? At 0, -8?
So vertical dotted barrier.
Vertical dotted barriers. I'm going to do this in a different color because I want everyone to understand that this vertical dotted line is not part of our graph. It's to help us draw the graph. That's all it's there for. So notice I'm not putting points on my x-axis. Do not put points because there are no points. This is where our function is undefined. So at -8, I'm going to draw a vertical dotted line, okay? When I go to draw my function's going to take off when it gets to that barrier. Then I have to draw another one here, right? Right through here. The problem with drawing that is that I already have a solid line, so it's hard to draw a dotted line on top of a solid line. So one thing you could do is, make it dotted here, and then when you get here, you could do little diagonal dashes like that. And then when you get down here, like that. That make sense? Any questions on the plotting of step 4? No, was that step 4? No, it was step 3. Step 3 is information. Okay? Now, moving on. Victor? There you are. Victor, step 4, what did we determine from step 4?
It was
Case
case A.
A, this is a horizontal asymptote, right? And it's going to be the x-axis. But I said only draw it at the ends, right?
Yeah.
What that means, this is very important. Our x-axis is the horizontal asymptote. This is our x-axis, but only at the edges. So what I want you to do is on this edge, just draw a dotted line out this side. And then on this edge, I want you to draw a dotted line out this side. Do not, I repeat, do not draw a dotted line all the way across. That will confuse you when you try and draw the picture. You'll see a dotted line, you think you can't cross it. All this thing at the edge tells you is what happens at the end. I know right now when I go to draw this, my graph is either going to come like this or it's going to come like this. I don't know which side, but it's going to come from one of these sides and get pulled in. All right? What happens in here doesn't matter. At the edges, it gets pulled. All right? Any questions at this point? All right. What is, Gabriella, the next step? Where's Gabriella? No? Oh, there you are. Okay. What's the next step? You didn't respond, so I was like, I got the wrong name.
Step 6,
Okay, which is?
choose test point.
Choose test points, which I didn't explain to you, right? So here's the idea. Right now, this is all we know about the graph, right? This is not a whole lot of information. I mean, it's a lot, but it's not enough for us to draw it. So what we have to do is pick some test points, points that we get to choose that will help us draw the picture. So what you're going to do is you're going to look at all your vertical asymptotes and x-intercepts. So I have a vertical asymptote, x-intercept, right? So I have 3 different kind of valuable points that they're kind of on the x-axis, right? This one is, this one kind of is, this one kind of is, yes? So I have 3 important points. What you need to do is pick a test point on each side and in between all of those. So what I mean is, -8, I need to pick something on this side of it. Any number that I want on the x-axis over here. So -9. Okay, so I'm going to put -9 here. I'm going to circle it, all right? Give me another test point. Notice I did not put a dot here. Notice I did not put a dot. Do not put a dot. It's not part of your graph. -9. Now, between here and here, anything you want. -3. You could do, someone else said -5, do -5. As long as it's between here and here, pick it. So you want -3? 1, 2, 3. -3, I'm going to circle it. Okay? I'm going to let Gabriella finish this out. I need one between here and this x-intercept now. So there's kind of an obvious one there, right? Just pick one, right? And then anything you want to the right of this one. 7, okay. How many test points do we have? We have 4. Do we have a test point in between every vertical I see? Right? In between any vertical and x-intercept, do I have them? Do I have them at the ends? Yes? Okay. So we have 4 test points. Now what do we do with these? You're not going to like this. We plug these into the original function. Okay? For x. Yep. So what we need to do now is we need to figure out what's f of -9, what's f of -3, what's f of 1, what's f of 7. Once we get past this step, everyone, we will be done. We'll be at connect the dots, all right? Well, yeah, we'll be done, but then it's still kind of challenging. Okay, what happens when we plug in -9? So we need our calculators for this. 4 times -9 minus 8. And then you want to divide that by -9 squared, blah, blah, blah. So does anyone have something for that yet, the whole thing? Take your time. At -9. Is anyone else getting -4.88, something like that? Yes? Okay, so you need to be able on your calculator plug these values in for x. I'm just going to put what the answers are at this point, and you need to make sure on your own that you can get those, all right? And if you can't, just talk to me. I can help you, but just not right now. I can help you after class, before class. So can you, for right now, just kind of take it on faith that these are the answers? Okay. Now we're going to put this information together. So I'm going to grab my black marker here, because right now in my graph, the only point on the entire picture that I've drawn that actually is part of my graph is that one right there, right? That's the only point. That's everything else is just kind of help guide me draw it in drawing the thing. So now I've created 4 new points on the graph, right? At -9, where am I? -4.8. So at -9, I should draw a point down here somewhere, right? And I don't even care how far you go down. What's most important is that the point is down. Okay? Now at -3, where am I? 1.3, I'm up a little bit, right? Yes? So I'm going to put a point up. Notice I don't care how high it is. I'm just drawing it. It's either below or above. That's the most important thing for us. What about at 1? Negative, right? So I'm down somewhere. And what about at 7? 0.19? I should be up a little bit. Okay, we're almost there. Any questions on that step? We're ready to put it all together. I'm ready to connect the dots. Are you ready? All right, well, here it comes. We're going to draw this the way we read a book, from left to right. All right? From left to right. The most important thing is that when you draw this, it has to still be a function, which means you can never have the graph do anything crazy like turn back on itself like this. Okay? It can't do that. It has to pass what's called the vertical line test, which I don't want to get into. But it shouldn't do any weird turning back on itself. Okay? Everything should be from left to right, nice and smooth. Let's see what happens. So this, you actually have to use your brain here a little bit, all right? You have to think about what you've determined, what all these dotted things mean. So this point I know for sure is part of my graph, right? So I'm going to imagine that if I were told I have to draw to the left of this point and to the right of this point, what would have to happen? So let me go off my sticks. Let's see if I can put anyone on the spot here. David? If I have to draw from this point to the left, what has to happen? I mean, am I allowed to just do anything I want here? What do I have to do? And why? So I'm telling you, you have to do something and you have no choice. Okay, yes? Like this? What is this thing telling you again?
Oh, it's a barrier.
This one's not the barrier, that's the barrier. This one's the what? This is the magnet, right? This is pulling your function to it, right? So as you draw this way, it should go towards that, all right? So from here to here, it has to flatten out towards that. Does that make sense? Okay? Now let's keep going, David. I'm going to try and draw. So now imagine you're drawing, from left to right like you're reading a book. We know we have to go through that point. Now, as I start to continue to draw it to the right, what has to happen? So now you have the barrier, right? And the barrier forces your function to either turn up or turn down, right? That's what I said. The barrier is going to be like this wall. You either have to do one or the other. So it looks like it goes down, right? That's what it looks like. But it doesn't go down because it looks like it goes down. It goes down because, David, what would happen if I turned this and went back up? I would cross through the x-axis, wouldn't I? And that means I would have had to have had an x-intercept there. This is the only place I have an x-intercept. So you can't go and draw it and create a new x-intercept. So that means you have to go down. Does that make sense to everyone? This is logic. You can't turn back up because you create an x-intercept that you don't have. So that means you have to go down. The picture is kind of telling you that too, but you can't trust it all the time. So it does that. Questions on that? Marcus, you all right with that? Okay, now I actually have to pick up my pencil at this point and go to the next point that I have on my graph, which is that one. And then I have to run through the logic again, to the left and to the right. And Brianna Garza is going to help us do that. So Brianna, I'm at this point right here. If I have to draw out to the left, can you tell me what has to happen? I'm going to have to turn up. Like I can do whatever I want in here. Now, can I come down and then back up? No, because I can't cross the x-axis, right? That's the only place you're allowed to ever touch the x-axis, right there. So I can like squiggle around if I want, but eventually I've got to just go up. And so that's what I'm going to do. I'm just going to draw it to the left, and then when I decide, I'm just going to go up like that. Okay? Brianna, to the right, what has to happen? From that same point, drawing to the right, what has to happen? It has to go up again. So, Brianna, why couldn't it go down? It would cross the x-axis. You're not allowed to. Only here, right? So that means you're just going to kind of wander around here, and then eventually the barrier is like, ah, and then it has to take off. All right? Tanisha, you're up. Once you get to a barrier, Tanisha, you have to kind of jump over and then go to your next point. This is the next point. So you have to think about what do you do if you go to the left and to the right. So Tanisha, to the left, what has to happen? Has to go down, right? Because the barrier's there, you have to go down. All right, Tanisha, what about to the right? Yeah, you're just back in kindergarten now, right? There's no barriers in the way. You're just going to connect that dot to that dot. Okay, now Tanisha, once I get to that dot, where do I go? To the next dot. Again, there's no barrier. Now, you don't want to come down and back up, right? Because then you'll create an x-intercept. So you're just going to go and connect that dot. Perfect. Yes? You want to finish it? What happens now? I have to go out to the right. Back down towards that blue magnet, right? So I'm going to go back down and just kind of get closer to that magnet. There it is. And we're done. Yes?
So, going back to the homework we just did, how we saw the bounce.
Bounce and cross, yeah, that thing?
So would that happen there?
No, we don't, well, it can happen, but
Well, not this, but
yeah.
do something like that?
Okay, so the bouncing and crossing thing is only for polynomials. Okay? So everything we did with polynomials is off the table. We don't have bounce cross anymore. All right? We have this new 7-step process. Unfortunately, yeah, that's the way it is. So what do y'all think? Let's compare it to the computer. The computer had this graph earlier. So there's their graph. This is theirs. And this is ours. Yeah? See, ours does this thing right here. That's this. Right? We've got this little UE shaped thing right here. We've got it right here. It's happening between -8 and 0. You can kind of see -8 and 0 here. What you can't see from the computer, you can't really make out that it goes through it too. It goes up a little bit and then comes back down. Maybe you can, but yeah? Okay. So we've done one rational function. All right, so what we'll do is we'll take our break now. We'll come back and we'll do the next two because the next two are the other two cases, right? This is an example of case A. I'll give you an example of case B and C, and we'll see where we are at the end of that. I'll give you some homework problems to do, and yeah, we'll see where we are in time-wise, okay? So 12:25, let's take, we'll do 15 minutes, 12:40. Sound good? You all do not